Hello everybody and welcome back. You should have already watched your review video 1 on Lewis dot structures and ions. This second review video is going to be covering periodic trends. So let's just jump right into it. Okay, so the first periodic trend we're going to talk about is atomic radius. And just a reminder of what that is, it's half the distance between the nuclei and the outermost shell or the ring of your atom. Okay, so remember just the structure of an atom. We've got our protons and our neutrons in the middle, and then we've got our negative electrons circling around. So the atomic radius is going to be half that distance between the nucleus, right? So where our protons and our neutrons are to our electrons on the outside. Now, just a reminder of our trends of our radii. So your atomic radius increases as we move from the right to the left, okay? And it also increases as we move down. So if we're looking at this, right? So as we move across our periodic table, these elements on the left-hand side are going to have a larger atomic radius. And then as we move down, they're going to be even larger, okay? So we're going to expect to find the largest atomic radii in the bottom left-hand corner of our periodic table. So, and here's our table. So again, as we move from the right to the left, these elements are going to have larger atomic radii. And then as we move down, these are going to have the larger atomic radii as well. So our francium is going to have the largest atomic radii overall. So let's look at a problem for atomic radii. So here's an example. It says, choose the element with the smaller atomic radius, silver or gold. Well, let's go back. Let's jump back. Here's silver, right? And here is gold. So remember, our atomic radius increases as we move to the left, and it increases as we move down. Now, our question was asking which one would have the smaller atomic radius, okay? So if we increase as we move down, that means if we're looking at silver and we're looking at gold, if we want the smaller of the two, we're going to find the one that is further up in the table, all right? So here we've got silver above our gold, so that's going to be our indication that silver is going to have a smaller atomic radius because radii increase as you move down. So if we're increasing as we move down, we can expect for gold to have a larger radius, and then our problem was asking which one would have the smaller one, so that is silver. Okay? Now let's take a look at ionization energy. So remember, ionization energy is the energy required to remove an electron. Okay, so when we talk about ionization energy, that's just how much energy do you have to actually remove an electron from that outermost energy shell. So a reminder, your ionization energy increases as you move from left to right, and it also increases as you move from the bottom to the top. So those elements, right, in the top right-hand corner are going to be those that have the highest ionization energy. Alternatively, those that are down here are going to have the lowest amount of ionization energy. So again, here's our table. So these elements up towards the top right are going to have high ionization energy, and then elements towards the bottom left will have low ionization energy. So let's look at an example. It says, choose the element with the smaller ionization energy, chromium or tungsten. Okay, so we want the smaller ionization energy, so the one that is further down and more to the left, right? Because if we look back at our trends, remember our ionization energy increases as we move from left to right and from the bottom to the top. So let's go ahead and find chromium and tungsten on our periodic table. Go ahead and pause, use your reference table. There's one here, but you guys should all have your reference tables as well. So when we find chromium and tungsten, here's chromium, right? So they're in group 6. Chromium's up at the top, and then our tungsten is below it. So they're in the same group, but they are in different periods. So if we look, remember our ionization energy increases as you move from left to right. That doesn't really help us because they're in the same group, but it also increases as you go from the bottom to the top. Now that means chromium will have a higher ionization energy than tungsten, but let's go back and see what our question was asking. It was asking which one had the smaller or the least amount of ionization energy. Because this tungsten was below the chromium, your answer here is going to be your tungsten. Okay. Finally, let's look at electronegativity. Just a reminder of what that is. That is an atom's ability to gain an electron. So remember, when we talk about electronegativity, the noble gases are stable, so this doesn't apply to the noble gases. So here, same with our ionization energy, our electronegativity increases as we move from left to right and also from the bottom to the top. Now our noble gases are stable, so they don't need to take on or donate any electrons. They're happy as they are. So we're really just going to be looking to our group 17 and to the left for these. So our halogens are very electronegative, right? So up here, fluorine is going to be our most electronegative atom, okay? Because again, just like our ionization energy, it increases as we go from the left to the right and from the bottom to the top. So here's some examples, or one example. It says choose the element with the smaller electronegativity, magnesium or calcium. Well, let's go back and find our magnesium and our calcium. Here is magnesium. And here is calcium, okay? So they're both in group 2. So we're going to look at the fact that ionization energy or electronegativity increases as you move from the bottom to the top, okay? So that means magnesium, right, being above calcium is going to have a higher electronegativity than calcium. And again, our question here asks for the element with the smaller electronegativity. Because calcium is below magnesium on the table and our electronegativity increases as we move up, our answer here is going to be calcium. Okay, and we would just reverse this depending on the wording of the problem. So if it said choose the element with the most electronegativity, you would choose magnesium. So if you're ever taking a quiz or a test or looking at practice problems, you just want to be careful and see if they're asking for the smallest or the largest radii, electronegativity, or ionization energy. Okay, so that was your quick review on periodic trends. If you need more help, go back and look at your original lesson on periodic trends, or you can always reach out and ask. Alrighty, I hope you guys are ready for video 3.